Hello, and welcome to another IB Math speedrun with me, Vince. So in today's speedrun, we're going to be starting and finishing chapter 6.2, which is all about angles and measures. So let's jump right in. So before we talk about angles themselves, we need to talk about some stuff about our favorite shape, the circle. So, well, you need to know that, of course, a line joining the center to the outside is called the radius, and a line joining two ends of the circle that passes through the center is called the diameter. Okay. And so an arc is a part of the circumference of the circle. We can say this arc here between these 2 points, that is an arc. The minor arc between A and B is the shortest distance, so this is the minor arc, and the major arc is the longest distance, the longer distance between the two. So this is the major arc, and the red line is the minor arc. And so when the major arc is equal to the minor arc, the 2 points are opposite each other in the circle. Yeah. Okay, so a bit more. We need to also know that a chord is a line segment joining 2 points in the circle. So say joining this point to this point, this line is called a chord. It's a straight line joining 2 points. And a secant is a straight line that intersects it. So it's like a chord, but that goes past the circle. So those are some definitions you need to know. Oh, finally, you need to know what a tangent is. And a tangent is a line that's, well, just tangent to the outside of a circle. So it touches the circle only once on the outside, and it is 90 degrees to the center. So finally, we need to talk about angles, and we need to talk about a unit called radians. So if you're in primary school, normally you're working in degrees, and you know there's 360 degrees in a full turn. But a very useful unit of angle that we need to know is the radian. And the radian is defined as the angle, 1 radian is the angle for which a circle with radius r has a minor arc of that length as well. So it's the size of an arc where the radius will be equal to the length of the minor arc. And so if we do calculate this, we find that there are 2 pi radians in a complete circle. So one complete rotation has 2 pi radians, and so therefore 360 is equal to 2 pi radians. So to convert from degrees to radians, we multiply by 2 pi over 360, and to convert backwards, we divide. So let's jump into some questions. A lot of it's just going to be conversion of radians. I'll be doing the I don't know, I guess I'll just do the odd ones, why not? So the first one is express each angle in radians. So the first one is 45 degrees, the third one is 270 degrees, the fifth one is 18 degrees, the I don't know is 80 degrees, and then the ith one is 120 degrees. So let's express each angle in radians. So we need to multiply each angle by 2 pi over 360. So what's 45? What's 45 times 2 pi over 360? Well, what's 45 divided by 360? 45 divided by 360 is equal to 1/8. So this is simply equal to 2 pi times 1/8. So this is equal to pi over 4 radians. Normally, it's very helpful to memorize these exact angles, just for reference. Okay, so 270, well, this is equal to 3/4 times 2 pi. So this will simply be equal to 3/2 pi, or 3 pi over 2. 18, well, this is equal to what's 18 divided by 360? It's 1 over 20. So we have 2 pi times 1 over 20. So this should be equal to pi over 10. 80 is equal to, well, 8 over 36 we can leave it as a fraction. So it's 8 over 36, or 4 over 18, or 2/9. So 2/9 times 2 pi will be equal to 4/9 pi radians. Finally, 120, well, we know this is 1/3 of 2 pi. So this will be equal to 2/3 pi. So normally we express radians, well, I mean, we can express them as degrees, both degrees or fractions. But if we're working in normal units, we normally express them in terms of pi, especially if the angles are stuff that we can divide 360 evenly or reasonably evenly by. Okay, so next we have express each angle in degrees. And the first one is pi over 6. Third one is 5 over 6 pi. The fifth one is 7 over 20 pi. The FG one is 7 over 4 pi. HI is 5/3 pi. Yeah, so we need to express each of these. So in this case, we have to divide by 2 pi over 360, or we have to multiply times 360 over 2 pi instead. So pi over 6 is equal to simply 360 divided by 2 divided by 6. So this is equal to 360 divided by 12, and it's equal to 30 degrees. Next, 5/6 pi. Well, if we know pi over 6 is 30 degrees, and we know that there are more or less 180 degrees is equal to pi radians, then 5/6 pi will be 180 minus 30, which is 150. At the same time, we could go 360, what's it called? 360 times 5 divided by 12 again, which is the same result. So next, 7 over 20 pi. Well, we have 7 over 20 times 360 over 2, since the pi's cancel out. So this should be equal to, well, let's plug it in, 360 divided by 20 divided by 2 times 7 is equal to 63 degrees. Next, 7/4 pi. Well, we have 7/4 and repeat the exact same process. So this should be equal to 7 times 360 divided by 8. So this is equal to 315 degrees. Finally, 5/3 pi. Well, we have 5 over 3 times 360 over 2. So we get 300 degrees. So yeah, that was pretty simple. Okay, next. We need to express each angle in radians correct to 3 significant figures. So the first angle we have is 10 degrees. The third one is 25. The fifth one is 110. The gth one is 85. And the ith one is 37.5. So for this exercise, I would get out a calculator. And it's as simple as punching into the calculator this angle times 2 pi over 360. So for 10, we should get 2 pi over 360. So this times 10 is equal to 0.7175 radians. 25 is equal to 0.436 radians. 110 is equal to 1.92 radians. 85 is equal to 1.48 radians, and 37.5 is equal to 0.654 radians. So these should all be the correct answers already. So it's as simple as that. Next, we need to express each angle in degrees correct to 3 significant figures. And the first one is 1 radian. The third one is 0.63 radians. The fifth one is 1.55 radians. Or actually, you might see this in notation as C. And so the C, the small c at the top, means radians as well. It's like another expression for it, just like how degrees has the circle. So we now have 0.36 radians and 0.01 radians. And note, these are not in terms of pi. So we don't have to express, like not all radians are going to be multiples of pi. So this is going to be simply the value 1, not the value pi. So we have to actually multiply this by 360 over 2 pi. So we get 360 over 2 pi, really. So 360 over 2 times over pi is equal to 57.3 degrees. So actually, I'll type them out here. So this is equal to 57.3 degrees. 0.63 will be equal to 0.63 times 360 divided by 2 divided by pi is equal to 36.1 degrees. 1.55 is equal to is equal to 88.8 degrees. 0.36 radians is equal to 20.6 degrees. And finally, 0.01 radians is equal to 0.573 degrees. So yeah, those should all be the correct values for the conversion of radians to degrees. Yep, and finally, we have our last question, and it is to find an exact value for the base angles in an isosceles triangle when the apex angle is 1 radian. So, we know the apex angle is 1 radian. And so the two base angles need to be equal to each other, and all three angles need to add up to pi radians. Notice we're working in pi radians, and pi is equal to 180 degrees. So there are pi radians in a triangle, and so this will be 1 plus, let's label this angle x, 1 plus 2x. So 2x is equal to pi minus 1. So x will be equal to pi minus 1 over 2 radians. So that is in the exact value. And so pi minus 1 over 2 radians is around 1.07 radians. And if we want to convert that to degrees, that is around 61 degrees each. So yeah. No, the book's just impossible. It says the value of the base angles should be pi radians, which is impossible since the entire triangle should add up to pi radians. So yeah, anyways, this is the correct answer, and I hope you enjoyed the speedrun, and I hope to see you in the next one.